further ado, pass over to Trystan.
Thanks, Matt. Hello, everyone. Thanks for joining. Okay, so yeah, we're going to talk about heatpumpmonitor.org today, and which has been pretty exciting, seeing how it's all come together over the last few months, with a lot of your involvement, and hopefully Tim Bones is on the call as well.
Hello.
Hello, Tim. Great. Yeah, so I'll do a little introduction to heatpumpmonitor.org, and then I'll
Can you make it full screen?
yeah, sure. And then I'll hand over to Tim, who's going to do a demo of the site, and then hand over to Glyn, who's going to talk a bit about hardware, monitoring hardware, and the kind of how you get the how you collect the data, essentially. Okay, so heatpumpmonitor.org is an open source initiative to share and compare heat pump performance data. It's at the moment a list of heat pumps, and there's about 23 with data, I think, so far. Yeah, so, and we were, most of you will probably seen, featured in the BBC recently. The geeks obsessing over their new heating systems, which there's great interest, and I guess it was quite a positive slant on heat pumps, which is always good. So why monitor and share data on heat pumps? So heat pumps are key technology for decarbonisation, as we know, enables efficient conversion of low.
How you leave the
Sorry. Enables the efficient conversion of low carbon and ultimately zero carbon electricity to heat.
Can't work it out to leave the meeting.
So you're not in it?
Well, I'm in a meeting, but
Who else is in it?
But I'm just meeting you, John.
But yeah, so field trial. There've been a number of field trials so far over the last sort of 10, 12 years. They've often recorded slightly worse than expected performance, and you know, good installation.
And that econ board that you mentioned was not made for your.
Sorry, Andy, just meeting you.
So yeah, good installation, commissioning, and control remains a challenge. So heatpumpmonitor.org is currently a list of 23 heat pump systems that are sharing their data openly, and the average performance of these systems so far are significantly above the average results from the larger trials. So one of the questions is what's the reason for this difference, and are there lessons that can be applied more widely in order to improve the average performance of heat pumps? So I thought I'd just go through a couple of just give a quick overview of these different trials that happened before. And one of the key things to, well, I guess, understand is that there are different boundaries to how we measure the performance of a heat pump. And the trials are very good at kind of splitting those boundaries out so that we can see, okay, we're just measuring the heat pump, or we're including in this the immersion heater, and so on. So the two boundaries to keep in mind are the H2 boundary, which is the heat pump compressor, and if it's an air source heat pump, the fan, or if it's a ground source heat pump, the pump that runs the brine loop. And then a H4 boundary, and that includes electricity used by the immersion heater and central heating pump. So in the original Energy Saving Trust, the Heaters On trial, phase 2, the average system performance factor, this is the H4 boundary, so including the immersion heater, was 2.45. And later, in 2013, there was another study called the Renewable Heat Premium Payment Trial, and this also, I guess, it also found results in similar similar range. The H4 there was, including the immersion heater, was a COP of around 2.3. The H2, so not including the immersion heater, was around 2.6. Then more recently, there was another study done by, well, actually, it was, I think it was a freedom of information request, or for the data being collected by the RHI MMSP meters, and someone analysed that data, and the results were pretty much in line with the other trials. So again, COP of around 2.7 over 510 heat pumps, and that's not including the immersion heater. So that's the H2 boundary. So heat pump monitor.org results so far, it's really interesting that the average is so much higher. So the average not including the immersion heater is 3.56. So it's an interesting question as to why is that the case. And I think that's I guess a key motivation of the project is to try and understand why these heat pumps are getting better performance, and are there lessons that can be learned and applied more widely. And then for people on sharing data on there's also the benefit of being able to see what other people are getting and how other heat pumps are performing, and sort of do a comparison and see how your data compares with someone else's heat pump. So, this is a nice chart that Tim put together. This is showing the heat pumps, or the cost of heat. It's the cost of heat delivered by each of the heat pumps, and compared with a gas boiler. So most of the heat pumps are costing less than a gas boiler to run in terms of the units of heat delivered. And in terms of CO2 emissions, you don't really have, you actually don't have to have much of a COP at all to have a break even with the way grid emissions have gone. But at a COP of 3.6, it's a 74% reduction. It's a fairly basic calculation. Or if it's a 2.7, so even the Energy Saving Trust results at COP of 2.7, giving a 65% reduction in carbon is still good from that perspective, but maybe not quite enough to have a financial break even, I guess. So without further ado, I will pass on to Tim, Tim's done a lot of work on the actual heatpumpmonitor.org website to put the list together, and it's been really helping people to get their data onto the site. So really big thanks to Tim for all the help that he's has been giving. So I'll hand over to you, Tim.
Thank you, Trystan. So hopefully you can see what I'm presenting.
Yeah, looks good.
Yeah.
So here is the website as it is right now. It lists 25 systems that people have submitted. I'll show you briefly the form that people would use. They can put in their name and email address and their location. There's then a section where they describe their heating system, which air source heat pump it is, what the refrigerant is, and so on. Mostly multiple choice questions with a few text boxes. We also ask them if they've got a buffer and what radiators they have. And there's then a section about the property that they're heating. You know, detached, semi-detached, how old is the property, how big is the property, what level of insulation it is. And then we ask them to provide a link to their EMON CMS monitoring page. They've got that set up. And the idea here is just to collect information about their heat pump, about their property, just so that when we're comparing different heat pumps and their performance, we can maybe get an understanding as to why they're different. And so on here, you can see there's different types of property, different ages of property, different sizes of property. And you can filter on these if you want to trim it down to, you know, just the semi-detached. Or maybe you want to see houses that have solid walls. So the filtering lets you kind of focus in on certain types of properties or certain types of heat pumps. Maybe you are interested in Mitsubishi heat pumps and see how they compare against each other. So that was one of the goals of this website, was kind of pull together the information as well as the stats for these kind of comparisons. Looking at, you can expand these rows to kind of see those details, whether they're using antifreeze or glycol, what their flow temp design is, and that sort of stuff. So the kind of the technical details. You can sort the columns as well. Click on the top to see who's using the most electricity, or who's generating the most heat, or who's got the best SCOP. And then you can click on one of these links. I'll pick on mid-terrace for no reason at all. And you can see how this heat pump has performed over time, as far back as it has data for. And then you can zoom in on certain periods, see what the COP is for that period. And then you can zoom in and then look at the nitty-gritty flow temperatures, heat output, and so on. This can be useful when trying to understand why a heat pump is performing super well or super badly. And then there's even more technical detail down here, which I think I might gloss over for now. That's right, Trystan?
Yeah, sure.
Coming back to here, now we've only got 3 systems that have an entire year of data. So we can only really trust the SCOP values we're getting from having an entire year. Some of these systems only started their monitoring in November or December. So you can't really compare the overall heat or electric very well. But here at the top, I have a link to look at the 30-day stats. Here, there's a bewildering number of columns. In this section, we have the overall heat, electric, and standby kilowatt hours for the past 30 days. The rationale here is, well, we can probably get 30 days worth of data from these systems. Still a few that are quite recent. And they've probably got similar weather if they're in this hemisphere, and they're a little bit easier to compare. So again, we can click to see who's winning in the COP. Looks like Glyn is winning. We can see, you know, how different systems consume different standby. And then we've also got kind of the average stats when the heat pump is running. So how hot is the flow temperature? How much heat and electricity is being consumed on average. And do you want me to show the charts as well, Trystan?
Yeah, great. Yeah, thanks.
Are they on the side?
Yeah, yeah.
Nope.
This graph. That, yes. Yeah.
Here we go.
You have to know the URL.
Yeah.
Very.
I haven't put the navigation in yet. Hopefully I'll get that in over the weekend. But here you can really visualize how these heat pumps are kind of performing as a cloud of dots. So vertical axis is the COP. Higher is better, so the left-hand side are going to be performing better than the right-hand side. The horizontal axis is the flow temperature. And you can see quite a strong correlation between the systems that have a lower flow temperature, they're getting a higher COP, which is what we'd expect, but it's nice to see it coming out of the systems we've collected. And then you can look at composite things like the difference between the outside temperature and the flow temperature. Again, you get a similar correlation. You can highlight individual points based on what refrigerant they're using, or if they're using glycol or not. I don't think we see any strong correlation here yet as to, you know, there doesn't appear to be one refrigerant that's outperforming the others. Glycol doesn't seem to make a marked difference either. Any other notable combinations I should highlight, Trystan?
Yeah, it is interesting that, yeah, I guess there's just not enough heat pumps yet to see any pattern with that color coding, you know, what kind of antifreeze method and what kind of refrigerant or you know, it seems to be fairly evenly distributed, whichever you select at the moment.
Yeah.
I think the return temperature over the last 30 days is the one that gives the strongest correlation.
Which is interesting. Yeah.
Which is only, you know, just like a slightly better correlation in the flow temperature between that and COP. Could you open the drop down?
Can I ask a question there? Why have you also got, because I'd expect a stronger correlation with flow temperature given what you've done. Do you have the equivalent flow one here?
Yeah, that was the first one.
Yeah, and what's the correlation before you? What's 0.06 and what was it on the other one, on the R squared?
0.75.
Sorry, can you flip back and see? Let's see what the. Oh, well, it is stronger, but why is it so?
It might just be a fluke at this point.
Well, of course it can be, but I mean, it's interesting. By the way, I've put a thing up in chat. It would be lovely if you'd put a CC0 license or something on these so that we can steal them for research purposes, because this is quite interesting.
Yeah, sure. Yeah, absolutely. I'm trying to think if there's another. I mean, everyone's welcome to open so it's heatpumpmonitor.org/graph.html. And then you can play about with this yourself there as well.
No, we have to have it fed to us. Come on.
Is it like Carnot efficiency axis? If you try that, Tim, percentage Carnot efficiency and then COP when running. I mean, I guess this is kind of the expected result. So maybe it's actually better to watch this on. If you select, x-axis flow temperature and COP on the y-axis again.
Yeah.
So one of the things that's interesting here is that there are some systems that are getting, they are running at much higher flow temperature and they're getting the same COP as some that are running a much lower flow temperature. So they're sort of higher performing at that. There's quite a wide spread of temperatures there for especially in the middle there. I mean, it might just be that the trend will become stronger over time, but I guess that spread of values is quite interesting as well, isn't it? Is that you could have a system that's running at 38 degrees achieve the same COP as one running at 34 degrees. Or in that case, there's one at 41 that's getting the same as 33. That one seems to be doing very well for its temperature, as it were.
Yeah.
So
this one up here. This one up here is the one ground source heat pump we have. That does seem to perform better than the air source ones. It's obviously only 1 point.
Yeah.
You see the question from Stephanie about whether it might be related to water heating.
It could be.
True. Yeah. That is something that we
Can't.
It's quite complicated to break out space and water heating, but it's something that would be great to be able to do. And yeah, because there'll be a whole load of stuff around. What temperature do you heat the hot water tank to, and if we could split out the hot water heating and also then look at the target temperature in the tank. And
are all these systems also doing hot water?
no.
So the easiest thing might be to filter first by just those that are and aren't. That might give you the simplest cut.
That's a good idea.
Yeah,
That's just a tick box
yeah.
flag, isn't it?
And that could come out.
Yeah.
You could highlight that on the color coding there, so you could have
Heating only.
heating only.
I mean, it might be
Heating
horribly
and hot
misleading
water.
because there might be good
Hot
reasons
water
for not
only,
doing hot
yeah.
water. Yeah, but
Yeah.
it might be easy to do, right?
Yeah, and there's a couple of there's 2 offices that are space heating only. So there's the Heat Geek office and John Andrews' office.
Yeah, the hot water information is already captured. It's in the table. If you view more information, you can see whether
Yeah,
doing hot water or not.
Right.
It's not available.
It's not filtered.
Not filterable, I don't think yet. But that's a good idea.
It is a good idea.
I'm going to disown it. I think it's possibly a bad idea on the grounds that you may be overfitting to other characteristics, like it's not a dwelling or something. But there you are. I've let the idea go now. I'm disclaiming it.
Is there anything anyone else wants to see while I'm here?
There's one ground source heat pump. What's that one? What was that? Ground source is mine.
So I think one thing I didn't clarify in the first part was, so all the heat pumps on here are most likely fit the H2 boundary, so that's not including the immersion heater. We haven't really added the function to add the immersion heater into the My Heat Pump app yet, but it's something that it would be great to do, and then have that information come through to the dashboard here. So
What
I
about-
guess when you're
What about systems that don't include immersion but do include central heating pumps? which boundary are they at?
Yeah, that's unfortunately, I had always thought that the central heating pumps were included, let's say, either within the H2 boundary or the H3 boundary, but it seems to be that the immersion heater is meant to be included in the H3 boundary, and then you add the central heating pumps afterwards, whereas in H4. So
are we looking at a mixture without knowing which is which at the moment of H2, H3, and H4?
Yeah.
Oh, that's shocking behaviour.
Well, I think the safe bet is that most of these are H2 boundary. That's then if you want to do a comparison with the Energy Saving Trust results, for example, you'd look at the H2 boundary and you'd compare, and you'd see that we're still, a full, it's like the average on here is 3.6. The average H2 boundary from the Energy Saving Trust and those other studies is all around 2.7 or 2.6.
So look, maybe another filter, if and particularly if a system changes over time, that might get more awkward. But if you were able to do a color coding or something by which boundary you're looking at, or the fattest boundary you have, or show them all as H2, so you can, I don't know how you do, but then you're comparing like with like.
Yeah, exactly. So I think because of the way that, let's say most Ecodans, the way the electric wiring works is that there's the supply goes to the heat pump, and then there's a cable that goes from the heat pump to the indoor controller, and the indoor controller will usually run the central heating pump. So all within that measurement, you've got your central heating pump, you've got your indoor controller, and the compressor and the fan outside. So essentially, you're covering some of the H4 boundary within that, but you're not including the immersion heater necessarily. So that would have to be metered separately. So yeah, there's a kind of a mixture of systems. I'd almost guess that most of them do include the central heating pump. That is something that we need to clarify.
Quite a few heat pumps have the central heating pump integrated into the outdoor unit, and quite a few modern heat pumps, with the newer refrigerants, don't use an immersion for hot water top up. And even heat pumps that use an old refrigerant, like R32, you can still get the immersion up to about the hot water tank up to about 55 degrees, which, depending on how you judge risk for that particular site, is probably more than adequate for most domestic properties. Heat Geek did quite a good video on that, but that's a topic for another discussion.
And for both Glyn and I both, maybe, I don't know whether for better or for worse, basically don't use our immersion heaters. And so our H4 boundaries, the data on the website is the H4 boundary for us in a sense, but it would be good to do some water quality testing. We're relying on that high throughput of relatively small cylinders as a kind of as the Legionella protection, but I'm not totally convinced that is valid. It would be the research behind it is quite complicated. So,
in case anyone was interested, I actually got challenged on this recently, so I've got a couple of good-ish papers. I'm going to drop me a line and I could share some links, which seem sensible. What you actually need to worry about in terms of Legionella.
Yeah.
In domestic circumstances. And
then I calculated for mine that if I did do a weekly Legionella cycle, it would drop my H4 boundary from like 3.91 to 3.86. So it wasn't like a major drop, but that did rely on some quite precise kind of immersion heater timing. So maybe not something that all heat pumps can achieve.
But yeah, 55 is probably safe for pretty well all purposes unless you're incredibly vulnerable.
Yeah.
Plus you have the advantage you can't scald yourself.
Shall
hand back.
we? Yeah, great. Glyn,
Yeah.
yeah.
So sorry, can I share my screen? I've just got a few slides here, a little short presentation just to talk a little bit about the hardware behind heat pump monitoring and how we've been doing it. On heat pump monitor, there's a mixture of systems. I think all the systems on heat pump monitor use Emon CMS, heat pump app. But there's a mixture of monitoring systems. Just trying to share my screen here. Is that working? Here we go. Yeah. Okay. So I just thought I'd start right at the beginning and just take a step back and look at the different types of heat pump monitoring. So the most basic type of heat pump monitoring you could do is just to measure the electrical input into the heat pump. So you could do this quite simply with a clip-on current sensor. Either use one of our open energy monitor monitoring units like EMO Pi or even TX V4 or any other clip-on energy monitor, and just look at the energy going into the heat pump. And you can actually get quite a bit of insight from this. You can see how long it's running for. You can see when it's cycling, and obviously see how much energy it's using. But I think quite a lot of heat pumps might have this information built in, but it could still be very interesting to be able to graph it. So the next level up from that would be level 2, which is where as well as monitoring the electrical input, you also monitor the flow and return temperature. And so you can do this using some temperature probes and just strap them on the flow and return pipes. And you want to try and make the best thermal connection you can as possible onto the flow and return pipe. So clear all the insulation out of the way. And the encapsulated sensors that we use have like a metal body. So if you put the metal body against the pipe with a little bit of thermal paste, and then maybe wrap some copper wire around to make a really good connection, and then cover it all up with insulation, that is actually quite a good. You get pretty close to the reading that you can get from using temperature pockets, which is what heat meters use. So using level 2 monitoring, we can estimate the COP. In the heat pump monitor app has a feature where you can use the Carnot efficiency to estimate the COP, based on the flow and return temperature and the power the heat pump's using. But this is only an estimation, and sometimes it can be relatively accurate, but other times it can be wildly inaccurate. If your heat pump has got a lower Carnot efficiency for some other reason, that wouldn't show up on this. So you can get a lot of insight by doing level 2 monitoring, but you certainly can't compare it with other systems, at least be very sure of it. And you should probably take the COP estimated value with like a good pinch of salt. And then we come to level 3 monitoring, which I think all the heat pump systems on heat pump monitor.org are using. It'd be good to be more, be able to filter by, which systems are, be quite descriptive about what monitoring systems each system is using. But this is what we've been doing as the main Open Energy Monitor level 3 monitoring bundle. So it's using class 1 and class 2 MID approved heat and electricity meters. And this is exactly the same as the RHI and MMSP monitoring metering package use. So it's like revenue grade, very accurate monitoring, and it's also totally independent from the heat pump itself. So to set up a level 3 monitoring system is a little bit more involved. If you've already got the heat pump installed, you need to get the heat meter installed on the primary pipework going to the heat pump. So that involves actually, installing it in line, so cutting the pipe and putting it in. So it's quite an invasive installation process. And the same with the electricity meter, that needs to be installed in line on the electricity feed. So it's possible to retrofit, but usually requires getting a plumber in to do that and drain part of the system down. Ideally, it would be installed when the heat pump was installed, which isn't, doesn't really add any additional cost for the heat pump installation apart from obviously the cost of the system itself. And unfortunately, heat meters are relatively expensive. That's where you pay for the accuracy. And sorry, coming back to this, and using a MID-approved electricity meter and heat meter also has the advantage that even if the web connected, the data login goes down or has an issue at all, the actual kilowatt hour values for heat and electricity are both stored locally on the meter, and you can just read off the screen there and calculate the COP manually that way. So it's a very very reliable way to monitor. And then we come to using manufacturers' monitoring data, which is quite an interesting topic. And this can be anything from level 2 to level 3 monitoring, depending on the heat pump. And there's lots of different ways to get data out of heat pumps. We've been experimenting with different ways you can grab data from some heat pumps have cloud services, like cloud with Mitsubishi, NIMBY, Uplink, and etc. And some of these have people have reverse engineered the API to get data from them. I don't think any manufacturers publish the API for people to use for this purpose, but they're quite well known on GitHub. You can find ways to get data from all those cloud services. But this data is really useful, but it often has quite low resolution. Because you're getting it through their cloud service, or you may be able to get data locally from the heat pump itself. I've got a Samsung heat pump, and I've purchased the optional Modbus add-on module, which was about £150 or so, but that gave me access to the heat meters data itself, which is great. But it comes with some. This is great in some ways, but also not so great in other ways, which I'll come on to. But I think most heat pumps have some way of getting data out locally. Valent have used eBus, EcoDan, there's a serial connection. You can use the same port that the MelCloud Wi-Fi connection plugged into to get data out. And there's various projects on GitHub which focus on how to interact with these heat pumps to get the data out. But nearly all of these local implementations, apart from the Samsung one, Samsung actually publish in official Modbus documentation. These all use reverse engineered protocols, which I guess would may be subject to change by the manufacturer at any time. And also this could be potentially warranty issues with sort of communicating with a heat pump in this way. It's not designed to be communicated with. It's one thing doing it on your own system, but if you were to offer it as a service commercially, you're on quite sort of slippery ground if you use a non-documented local reverse protocol. But I think that the main problem though with you getting data directly from the heat pumps, beside the complexity of doing it, it's often you've got to be quite a tinkerer and quite technically involved to get the data out. Any of these methods all require quite a lot of work, and they're all very different between heat pumps. But I think the main problem is heat pump manufacturers don't give any certification at all for their monitoring, and we've found the manufacturer's monitoring data to be highly variable. Sometimes it matches the independent MID-approved monitoring system pretty well. Other times it can be wildly out. My Samsung, for example, is about 30% out. It underreports the heat delivered by about 30%, which is quite a lot. And that's down to the temperature sensor readings on the flow and return. That's inside the outdoor unit in the heat pump, basically underreporting the temperature. And I've verified it with several sets of temperature sensors, and it's definitely the heat pump that's out. So if you can get data directly from a heat pump, it's could potentially be a low-cost way of doing it because you don't need any additional hardware. It's probably not a very time efficient way of doing it because it's quite a lot of work. But if you do manage to get the data, then it's probably really useful to use to optimize your heat pump. But probably you can't necessarily use that data to compare with other heat pumps. So you need to be a bit careful there. I mean, it would be great if manufacturers were to provide certificate, approval for their monitoring, to say, look, the output from here is very accurate. But a lot of them come with, I think Valence, their new app, actually the COP value they give via the app, it comes with quite a caveat to say that this may be, may be inaccurate under certain scenarios, under certain circumstances. So they're sort of admitting that it may not always be correct. And there's also a question of, even between the same model of heat pump, there could be variations in manufacturing processes. That could mean there could even be variation there. Because heat meters come with like a matched pair of temperature sensors that have been tested in the factory and calibrated to be totally identical. Because especially when the delta T, the difference between flow and return, is quite small, if you're out by even half a degree of a degree, that could be like a kilowatt of heat difference, which is quite quite considerable. I'll just skip over these boundaries again. This is what Trystan talked about. And the different boundary. Yeah, most of the systems that we monitor are H2, or can be considered H2 boundaries. So choosing a heat meter can be quite complicated, because there's quite a lot of heat meters out there. This is just an example of the heat pump monitoring bundle that we offer at the moment through Open Energy Monitor, and we've selected a few different heat meters there for different sizes of heat pumps. And this bundle is like a pre-provisioned bundle. It's all set up and configured. It's basically plug and play, apart from the fact that you need a plumber to be able to put it on. But it's actually aimed at. We work with quite a few installers who install this as they're installing their system. It's like something they can offer as part of their installation service, which I think is really great to have installers on board, because it really helps obviously them learn about the system, and the customer learn about the system as well. And it's quite suited to being installed when the heat pump is going in, and you can see there you can choose the heat meter to suit the output of your heat pump, and then choose whether you want 1, 2, or 3 electricity meters, or single 3-phase. But in terms of those types of heat meter, we selected here a number of heat meters. I'll just try and give a brief overview of kind of what we look at when trying to choose a heat meter, because if you're totally free to get your own heat meter and use our Open Energy Monitor software and build your own system that way. If you're technically minded, that's totally possible. So these are the things that we look at with heat meters. So there's 2 main types of heat meters, which is quite interesting. There's the ultrasonic heat meters. Actually, I should say how a heat meter works. So a heat meter works by measuring the flow of the liquid going through the pipe, and the temperature difference between the flow and return. So it'll have 2 temperature sensors and a flow meter. Obviously, temperature sensing is quite easy to do, but flow metering is a bit more involved. And so there's 2 types of flow metering. One is ultrasonic, which is used by most heat meters on the market, apart from Sontex. So heat meters like Camstrup, Sharky, these all use the ultrasonic principle. This works by, I've got a little diagram somewhere here. This works by having ultrasonic measurements through the liquid. I think they send like an ultrasonic pulse in each direction, and then they time the time it takes for the pulses to come back, and you can get a reading for the the speed of the liquid going down the pipe. The advantage of that way is it's quite low pressure drop, because the pipe is quite free. There's nothing in the pipe, but these meters can be affected by things like turbulence and air bubbles or any debris in the system. But they mostly work pretty well. We mostly use ultrasonic and had very few issues, but occasionally you do get an issue if it's not been installed quite correctly. And they can't support glycol, so you can't use a ultrasonic heat meter if your system has glycol in it. So the other type of flow metering method is this oscillating fluid oscillation principle, which is it's kind of like, it's pretty amazing stuff. Sontex use this. Apparently, it was developed by NASA, and Sontex took it on. But as far as I understand it, it's the liquid goes through like a constriction, like a little nozzle, and then it's ping pongs the liquid between these two piezo sensors. With a little jet of liquid hits these two piezo sensors, and it ping pongs around. And at the time it takes for it to like ping pong around between these little chambers is equivalent to the speed of the liquid. Pretty amazing stuff. But this does come with a slightly higher pressure drop because there's a little constriction in the pipe. But it is less affected by turbulence and air bubbles. A much more forgiving system. You can't really install it wrong. You always guarantee it'll work really well. But they are more expensive since you need a larger heat meter to achieve the same small pressure drop. And you can also have a glycol calibration. That does need to be applied by the manufacturer though, because these heat meters are used for billing purposes. Often they're quite like, and they've got lots of anti-tamper mechanisms and things, so you can't adjust the calibration of them once it's been set. So for a heat pump, you want the heat meter. You don't want the heat meter to constrict the pipe too much or constrict the flow of liquid, because heat pumps have higher flow rates generally than gas or oil boilers. So being able to maintain a good flow rate around the system is very important. So you want to choose a heat meter which has the lowest possible pressure drop, but the price of heat pumps, the heat meters jumps up considerably as the heat meter gets larger. So you can use a large heat meter with a very low pressure drop on any size of heat pump, but it would just be very expensive. So to shoot, you don't want to spend any more money than you have to. So we've spent a bit of time going through all the manufacturers' data sheets and picking out the pressure drop on all of them and comparing them all. So we've got this little spreadsheet where you can put in the kilowatt output of your heat pump, and it calculates what's the expected flow rate and what the pressure drop is at the different flow rates. And John Cantor actually wrote a really good page on this on our Open Energy Monitor heat monitor GitHub page. It's well worth a read. And finally, this is just a couple of examples of the system installed. I don't know if you can see my cursor, but on the right-hand side here, there's a heat meter in the middle of all those pipes, and then there's a little pocket on the right. The heat meter body is generally installed on the return pipe. So after the return from the cylinder and after the return from the central heating. And then the sensor pocket is installed on the flow pipe. And the return temperature sensor is integrated into the body of the heat meter. Actually, the picture on the left shows it a bit clearer. You can really see so this temperature sensor sits in a little pocket. So the sensor is actually in the flow of the liquid to get the best possible temperature reading. I think that's it. That's a quick overview of hardware for heat pump monitoring. Is there any questions?
Yeah, that's great. Thanks, Dan.
Yeah, I've got a couple of questions. Which I put in the chat, but now I don't know where they are now. But the last one I was thinking about extracting flow and return temperatures from a system which doesn't have a documented API of any kind. And I wish I could put additional temperature sensors on there and transmit that data. But I wondered whether something like a Sontex 531, which is what I'm using, would have that as an output that you could take alongside some of the other outputs that obviously are needed, such as the the amount of energy and the amount of heat.
What is it you're after? The temperature of the flow and return reading?
Yeah, because I noticed you were talking about that earlier on, the flow and return, and some of the things that are used in the monitoring system. So I haven't got that. I mean, I've got it manually. I can look at it, but I don't have it, in data that I could transmit.
So most heat meters, they'll output that data we use MBus to connect to the heat meters. And when we connect to the heat meter via MBus, you get a whole load of metrics, including flow and return temperature. And a lot of them calculate delta T for you as well. And they give you the flow rate and they give you the energy and the power.
It sounds like you've got a configuration issue there, Paul. Like, I know you have. We've been back and forth about the MBus readers, haven't we?
Well, I've no problem with the MBus readers. I have an MBus reader that works with the Sontex.
Yeah,
so,
great.
I sort of gave up worrying about why the other one didn't, and it might have been just it was one that came out on a Friday or something. But no, I'm looking at the data right now, which comes out, a snapshot of the data that comes out from the Sontex, and it doesn't include flow and return. So
it's probably that thing of Sontex. They've got multiple pages of information. You need to send it a command to get it to advance onto the next page of information, which will contain the flow and return temperature. We can help you with this.
Okay, well, I think that's probably enough of an answer. I mean, I could always just try Googling that.
It's a bit awkward. Yeah. Maybe we haven't documented it super well. I think it is there under the Emon Hub interfaces documentation, how to advance it onto the next page, which I think sounds like. I'll post a link on the chat and we can follow it later.
Well, that's great.
I was just thinking, there's a couple of people on this chat who are also contributing data to heatpumpmonitor.org, and I wondered whether anyone else would like to say something about what their reflections so far of that. I know we also got John Cantor here, we've been working with on heat pump monitoring, as you checked earlier, since 2011. So quite a long time now. So John pioneered a lot of this monitoring, and also showed that was the first example that I've seen of a heat pump consistently getting COPs of 4, and so I don't know if John, you want to say anything, or if anyone else would like to share some of their reflections.
No. Can you actually hear me? The microphone.
Yeah,
We can.
we can hear you, John. Hello.
Hey. Took me a while to get to be able to hear. I was sort of interested that look on all these sites and sort of wondering what's going on. I'm wondering also if they are trying to work out why their systems are doing this or that, and how we can sort of deal with that. In other words, do they want comment and other people? Because it's partly how to drive the system, isn't it? How you drive, how you adjust, how you run the system. I just wondered how that could work without it being sort of too clumsy with lots of people chipping in. What do you think? Do people, would people welcome commenting or discussion on individual systems? Like,
I think people are putting that data on there, aren't they, publicly? So they would be quite happy, I guess, for people to, be discussing it. That's hopefully, one of the outcomes of heat pump monitor. That'd be to encourage.
Maybe there needs to be a way for. Does the website need to have a top? I don't know, like a topic or yes, I'd like people to reach out to me if they've got comments. I don't know.
I don't think people put it on there if they didn't want to share the data, but
yeah, some people have threads on the forum, I guess.
Yeah.
Yeah,
I suppose there's no
Well,
way
what-
to contact someone really. That's the thing. There's no contact details. So
Can you? I mean, I'm just observing here. The fact that someone's prepared to publish their data doesn't necessarily mean they want to have public comment on it, but some definitely would. If you had an additional data field in your static data saying welcomes comment and a link you could click on to post it, then that would. I mean, it's all work for someone on the system side, but it would take away that ambiguity, right?
That's true. Yeah.
And I have a comment here because what John says is right, because of course it would be, because it's John. John built my first heat pump for me in 1993, was it? The water source heat pump. So yeah, the guy knows what he's talking about. But the one thing which hasn't been discussed here, which I found quite interesting when I was in the Mitsubishi heat pump trial, and I was getting all the data, was that how you run your heat pump for an Ecodan makes a lot of difference. If you leave it on the thermostat, particularly if it's not well adjusted in other ways, it's going to start turning off and on as it reaches the flow temperature, whatever. Whereas what I've done with mine and got a much higher COP out of it was to find out what its optimum running times were, and I found that 2 hours was about right for my heat pump, and so I'd have it turning off after 2 hours and then back on again after an hour or 2 hours, and that way I got a higher COP out of it. So I think there's a lot of interesting stuff to look at in how heat pumps are run.
Yeah, absolutely. I think that's it's a really good point. It might be a large part of the difference between the COPs, the average COPs in the sample so far, I guess, and the previous studies is that it's sort of a self-selected group of enthusiastic heat pump owners who are happy to spend a bit of time tinkering in a way, isn't it?
Because there's so many options and settings with the controls. And it's not always obvious which is the best mode of operation for a heat pump, and some experimentation is often needed, and that's where actually the monitoring comes in, because you can actually tweak things and look at what difference it has. Certainly without having a monitoring system that's this detailed, it'd be incredibly difficult, I think, to get your heat pump. You can get it pretty good, I guess, just with using the basic settings, but if you're trying to really optimize it, then I suppose that's the difference.
I was very fortunate that the field.
We lost someone.
We lost me.
It's frozen.
It's the EcoHome black helicopter that swooped him to cut him off.
As long as his heat pump's not frozen, we're okay.
On the performance and what affects it stuff, have you tried to fit any models on using so there's the flow temp versus COP, but on the same heat pump you could try and do day-to-day fit modeling on COP with cycling and outdoor temperature and some other features, and just see if you can figure out how much some of these things make a difference.
Would you be proposed to actually people change their regime, or just do it as a natural experiment and see?
I think you could do either, couldn't you?
Yeah,
I think you start try and fit a model without asking people to change anything, maybe.
Difficult to know, obviously, as all these things, which are the determinants and which are the, but yeah, interesting. Hey, that could be an auto feature in heat pump monitor.org, right? You put it in a different regime and it says, right, that worked better.
Yeah, I mean, these guys have already built an amazing thing, so not demanding features, but it'll be cool.
Yeah, no, that's great. Yeah, that would be, I mean, it would be really good to do some more trying to fit the data with models and adjust that and see how. Yeah.
I think it's quite early days, really, isn't it? For
Yeah, it's-
monitor.org, it's quite new. We've only just, I mean, a lot of the monitoring systems are quite new as well. There's not a huge amount of data in some of the systems. Most are less than a year, aren't they? And certainly the website itself has been, developed fairly recently. So yeah, open to ideas.
If you are passing a year for many of them, you know the ability to run data against your models, for example, against your existing data, and then try them with tweaks would be really, really nice. I mean, as Stephanie's saying, not to give you guys more work to do, but you've got a living lab there.
Yeah.
One thing I wonder about with this though is if you are, you have your data, maybe you have a year's worth of data, but if you've made tweaks at various points throughout that year, then would there be a way to just have a note or something? At this point I made this change, right? You'd have to know.
You have to segment your data, exactly.
Can't.
Yeah.
It's like the H2, H3, H4 thing. If you start adding more things inside the boundaries you're recording, you've got to record in the data. Either continue to record the old streams in parallel, or say this is now moved to be an H4 or whatever, because otherwise you get incomparable data. But yeah, luckily not my problem.
Yeah, we don't currently have any way of adding tags, like time-based tags to data in the underlying application, which is EML-CMS that we're using for this. So it's something people brought up at several points. But yeah, it would be nice.
You might get away with a stream of just a separate running along everything else says on this date this change happened on this day, so it'd be very, very sparse. It doesn't need to go into your main database, right? It's almost entirely for post hoc analysis.
That could be hosted on heapmonitor.org, couldn't it? That kind of tags in a way. So, yeah, that would be actually a lot easier.
Yeah, you could tag, change where the comp curve down a few ticks, or
and
stay for a week.
and so it should clearly have a date tag, sometimes time in it. Some of it should be machine readable. Most of it can probably be human readable. I mean, it might be really simple.
I agree that would be useful, but I'm not sure you actually need it to fit that kind of model, because if you're just fitting a model on features like flow temp or like cycle time or something like that, like it will be inherent in the data that's happened. If you've changed the monitoring setup, then for sure. But I think most setting changes you make would show up in the data, because like the flow temp would check, like the flow temp relation to outdoor air temperature would change and things like that.
I mean, you're probably right, but I like to flag these things because you'll never remember in 6 months' time why is it suddenly changed or whatever. And if you just had a little note saying put the thing on the right way up this time, whatever it was, then you go, so whatever.
Are you talking? Is that Stephanie? Are you talking about with the model? Is it like a dynamic model that's sort of simulating the flow temperatures in that kind of detail, or in real time, as it were, or is it? What could you explain?
Yeah, good question. Fluid idea, but like fit some sort of time series machine learning model with input features being things like outdoor air temperature, flow temperature, something about cycling, like time since turned on or something. Like I think you like have to play with what features worked, but essentially like trying to fit a model with various features that predicted COP on the basis of other features.
Yeah,
it sounds like sort of thing that you pay data science to do, right? Which is work out what variables are actually important to the output, and then sort of phase two, and you go on reevaluating on the phase two, then you fit to those variables.
I mean, it'd be
of
great.
All the data you've got.
It'd be great to work with people who could analyze the data in, to take it to that next step in a sense.
The truth, of course, is you use so much CPU power finding those variables that you actually use it in sort of immersion heating.
Yeah.
I'm thinking that even if you had data scientists engaged in the project, you've got to kind of brief them as to what the kind of variables might be. And probably the way to do that is simply just to have, I think somebody already mentioned it, a simple page associated with each heat pump, which has just got these kind of observations on it. And then by scanning through all those, they start to pick out what are the features that should be in models, rather than try and sit here now and try and predict them.
You can just brute force it though. You know, computer time is cheaper than think of human wet wear time. Sometimes.
Could I ask a quick question? No, Dom, go on.
No, you go on.
Yeah, it's just because obviously this is like super important, and it seems crazy to me that someone had to do like a freedom of information request to get the MMSP data, because it's like such a vital thing of everything that we're trying to do. And I just wonder whether like what you see as the next steps in terms of like, have you had like academic institutions approach you, or like, you know, is there like, you know, funding required to like try and push this further, or because it just seems like such a fundamental thing to have this ongoing monitoring. And do you see it having like thousands of feeds, or like, you know?
Yeah, because I guess like, yeah, that's a good question. Yeah.
It's sort of taking over, isn't it, from the R, because the RHI has come to an end. There is no MMSP package anymore. So, you know, if we didn't do something, there wouldn't be any heat pump monitoring going on.
I get but then there are a number of large heat pump monitoring trials that are ongoing at the moment. So with much larger numbers of heat pumps. So it'll be interesting to see what the results are from that. I guess like the whole motivation here is to do something that's open and that the data's actually just available straight away and people can look at it. And I mean, I guess it all came out of us all just sharing screenshots of our dashboards on Twitter and on the forum and that kind of thing, and chatting about it and thinking, oh, it would be a good idea to, rather than just have us all randomly, you know, posting about this, to have it on a list, a directory of the people who are happy to share their data in this way. Whether it should, I mean, we don't really have like clear ambition. It's just more, and we're good to get this data out and share some data, you know, have a discussion. And it was, I guess, like it's being featured in the BBC was, you know, like within a couple of weeks of launching the website was nice. We've got as far as we want to get. Probably get. I don't know. But yeah, I think we're happy to keep building it, and you know, and it's nice that I don't know. This is, I mean, I guess, you know, Glyn and I do the monitoring as our day job, so you know, in a sense, we do get something out of this, but it's also nice to be doing it without a ton of like specific grant funding that is for a certain period. So this is just like quite an open-ended thing. It's not, doesn't finish next year and then it's finished. You know, it's something that we'll just keep tweaking and building over time, I think.
But why not consider having on the side? Look, I mean, you're talking someone who's only worked for the man for a total of 1 year and 6 weeks in his entire life. So I totally understand that. But supposing Innovate or someone would cough up, let's say, I'm just thinking out loud here, 100 grand a year for someone to do it, a model of your stuff, a copy of your stuff, and RHI based data, for example, so that doesn't go away. So you could carry on doing what you want, but then someone is just using a clone of your system to manage that stream of data. So it's it continues to be available. That strikes me as being a perfectly sensible thing, and it doesn't need to get in the way of what you want to do every day.
Yeah. And I mean, I guess if there was a way for there to be funding to help householders to put in monitoring equipment and participate in this kind of thing, that would also be, you know, because not cheap. For
No,
materials.
and that should be another strand. I mean, absolutely, is supporting users to participate in the system, to understand what their own systems are doing and so on. But again, I'd say that's a third thing, right? You don't have to do all of them to do any of them.
Yeah.
Tom, you were going to say something, and then I cut you off.
Sorry. Responding to it, I think Stephanie was. I think her idea is basically what I do is a daily average, and you could plot. I mean, you could do it every hour, but so like flow temperature against COP of your own system. You've done it for the group. You could do COP against flow temperature for your own system somewhere in heat pump app. Based on the daily average, if there was a way of collating that into a time series. So that's one idea. Second is normalizing the data that's on heatpumpmonitor.org to the square meters of the property. So you could normalize the heat output and the electrical input kilowatt hours per day to the floor area of the dwelling. That might be a useful one to look at as well.
Hey Dom, you might want to add in heating degree days normalization in there as well.
It's kind of in there already, isn't it? Because,
is it?
Yeah, I mean, yeah, I suppose. Well, it's not, but they're all. If you're looking at the same 30-day period, I suppose you could look at geographical.
Or do it by region. Yeah,
by
exactly.
Region.
But Scotland isn't London, right?
It's Dorset or something. Or,
no.
Yeah.
But yeah, I agree. Normalized stuff is great as well because it makes it much easier to eyeball stuff.
Do you save over the station feed, or are you pulling that from somewhere else? Just live.
We generally use Metis data for that location. So you set it based on the postcode of the installation. But some systems on there have outdoor weather temperature sensors, and they get data themselves. But we found that the Met Office data matched pretty well.
You still need to pick your base temperature, which is a whole separate philosophical argument. But yeah.
You know, the trouble with the real outdoor temperature is it's so affected by things like sun and other stuff like that, which will put a bit of noise on there, really. Certainly if you're trying to do comparisons.
I think probably using like the Met Office data is probably better for comparisons because I've got an outdoor sensor from the back of the heat pump, but when the sun hits the wall behind the heat pump, it kind of reflects and you get a spike which is not the actual air temperature.
It's almost as if they'd spent ages trying to get rid of those effects in their official recordings, right?
yeah, it's almost like professional of it. Yeah, but they don't have. They obviously don't have temperature measurements everywhere. So what you get when we use the Met Office API to return temperature, it is like a calculated value. I think they base it on the weather stations within the applied factors.
But something like HDD is pretty robust anyway, and it's a normalization factor. You're not throwing away the original data, so I don't think you have to overthink the pudding on that one and the plumbing on that one.
Coming back to this business of categorizing the actual building that's being measured, it seems to me there's some quite useful data that comes from the original heat loss survey. So, I mean, although obviously those are manually calculated, but they're a little bit more precise than something like, oh, this is a detached house on a hill. So if you're trying to do some analysis of a big sample, it'd be quite nice to have data like that.
English Housing Survey and so on, all of that's good. I've just been into all of that. So that's got archetype, it's got, I mean, you can use the EPC certificate, for example, to give you things like floor area and construction and so on, which is quite nice. There's quite a lot of good data out there.
Is it, sorry, you talk about EPC, are you joking?
I'm using, in terms of the static data, it's okay. You get things like the floor area and the location and all of that. You may or may not believe any of the rest of it, but I think the static data is reasonably believable. And age.
Did you get that by the API for a property?
You can get the floor area.
That's cool.
Yeah.
Called
Mm.
And
open,
age as
open
well,
data
isn't there?
communities, I think the API. The
Wow.
age is extremely questionable in my experience.
Is it? Interesting.
Yeah.
Okay.
I just watch the way that people do EPCs, and I'm just amazed that anybody pays any attention whatsoever to that. But watching
You old thing.
somebody doing a proper heat loss survey and filling out the whole damned, heat engineer forms gives me a little bit more confidence that something, that you got something that describes the house in a better way than anything an EPC could do.
Well, doesn't mean if you have nothing else, you shouldn't use what you have, even if it's not the gold standard.
Yeah, no, I agree. But I think most installations, somebody will have done.
Yeah, no, I hear you. I was thinking a bit more generally. I'm writing a paper about getting people off gas boilers and onto heat pumps, so they won't have had the heat. No one will ever have thought about the amount of heat needed even when they were installing the gas boiler. But yeah.
Yeah, but you could. One way of doing things, which I wish I'd done it this way actually, is to do the whole heat loss thing and replace radiators and what have you before switching heat sources. And I think that would be quite interesting.
Oh, maybe. You know that I'm doing this thermochromic sticker thing. I don't know if I've mentioned this before. I mean, that's another way of doing it. You whack them on your radiators and see how far down you can turn your flow temperature before you're starting to get cold, and that gives you another cheap indication of whether or not a radiator is likely to need to be replaced with heat sources. Maybe that's a distraction, but it's a dead cheap thing to do.
I was thinking, Tim made a couple of good points about his motivations for contributing to the project. I don't know if you wanted to mention those in the video, on the video, Tim.
Yeah. I did it for me, to be honest. I wanted to see how my heat pump compared to everybody else's. I wanted that warm and fuzzy feeling that it was okay. So yes, primary motivation is to let heat pump owners compare notes, see how well they're doing, see if they need to tweak their system to do better. And then secondly, to show non-heat pump owners that they can have a well-designed, well-performing heat pump. They might not know how they can get that just by looking at heatpumpmonitor.org, but it does show potential for very well-performing systems. And to try and counter some of the horror stories you might get in the press, which of course you will hear about the bad stories and you don't hear about the good ones because the good ones are just doing what they should do.
Yeah.
Well, on the subject of that, did you see today's flurry of stuff about Boston where it got to minus 30 degrees centigrade and a whole bunch of new heat pumps behaved just as expected? And obviously a few had some hiccups, but so did a lot of fossil fuel. So that was quite good. Mainstream media was doing a balanced picture saying it wasn't perfect, but neither was the fossil fuel stuff.
I think so. Heatpumpmonitor.org it's also very useful to validate manufacturers' claims about their units. Because there's certainly been a lot of the debate on in various heating engineer circles about the performance of newer heat pumps and how newer refrigerants are game changers. And yes, they can get you to higher flow temperatures, but we haven't seen any strong correlation between or any correlation that I can see really between newer refrigerants and more modern heat pumps and performance. I mean, there's lots of factors.
probably not quite enough. There's a case of also not having enough data points, isn't it?
Yeah,
as well?
yeah.
Well,
Some-
is it because they're there? Is it because the new refrigerants are there because of lower global warming potential rather than because they're actually better refrigerants? Is that why?
Well, but they're
You
Oh,
know,
are they
that is
now?
a very good
They
thing
are
to have for
marketing it,
sure.
yeah.
I mean, it is the way things are moving, and it's really good that they do have low global warming potential for sure. But it's just interesting to see when manufacturers claim higher scopes if they get get them in practice. I think it'd be good to explore that in more detail. But possibly maybe the fact that they can do high flow temperatures means that installers would be tempted to put them in running at high flow temperature and not upgrade as many radiators, which then overall results in lower COP.
I mean, there are going to be hard to treat homes. This is what I'm writing about now, which is where you may have you might be in a listed building or something. You can't just whack in bigger pipe work. You might be on ridiculously small pipe work and rads, in which case, or you might be able to run, I don't know if modern heat pumps will now allow you to do this, but run some bits of the property at a higher flow rate than the other so that you can deal with the more difficult bits that way. But I think some people are going to need the highest flow temperature they can get realistically to drop a heat pump in. Oh, sorry, you know all this better than me anyway.
Going back to sort of next steps and like what to do next. I was curious, is the data like is it easy to download if someone wanted to come through? If an academic popped up and said, oh, I want to take all of this and start making models, or
Indeed.
start writing papers.
Yeah, good question.
And stick a license on it when you do, right?
Yeah. We should probably need to think about how how to communicate that and how to. I mean, it could do like a guide, couldn't it? About, because you can do it now, but you need to know where to go to do it effectively. So
the APIs are open, aren't they?
Yeah.
Data is there publicly.
So because
there is no download button.
well, if you have to know at the moment, you have to know to go to. You click through to go to the dashboard, and then on the left-hand side in the menu, you can get to the feed list, and then you can see the feeds, the public feeds behind that dashboard. That will you can then bring up the graph view, and you can download CSV data through that. But it's not like it's not like a document. It's not a document.
Yeah, you possibly want to make a really dumb give me data. Well, I don't need to know. And I suggest, if you can, stick it on CC0, which is what Andrew Katz or someone would recommend.
Okay. Yeah, we could probably do with some guidance on what to do on that front.
Well, I'm not your lawyer, but Andrew Katz might be prepared to be your lawyer.
CC0.
So
Andrew
Katz, K-A-T-Z. Yeah, he advised me ages ago, because attribution is really difficult on data, that in general, if you possibly can, make all your data CC0. So that's what I do with all my data sets that I can bear to do that with. I stick CC0 on.
I know, like I'm sure I remember some open data projects in the past. There were some very clear kind of sign up terms and stuff to do with data sharing and all that side of things that isn't really in place yet. It would be good to.
No, you may not, of course, implicitly have enough permission from your participants for that, but you've got few enough that you could probably write to them all and ask them nicely now to allow on whatever license you like. CC0 is effectively public domain, right? So you let it loose into the world at that point.
Yeah.
I think we've already asked the users that question.
Okay.
I don't know if we phrased it legally enough, but we do ask them, are you happy for this data to be public?
Yeah, but public yeah. Anyway, whatever. If you've got agreement, you're probably not going to get sued. But maybe it'd be nice to, if you decide it's say CC0, you say that explicitly for every further sign up.
Yeah. Well, we're thinking of reworking the whole system maybe developing version 2.
Mm.
So we'll have a think about what different questions to ask participants, as well as the legal aspect of CC0.
Yeah. I mean, not everything necessarily, but data, yeah.
And
I mean,
Yeah, and on even on your graphs, put a thing at the bottom saying you're allowed to use this for, you know, on maybe a CC what B by 4 or whatever it is, one of those by attributions, because it'd be lovely. I'm just, you know, I'm trying to get data set up to my local borough's data thing at the moment, and there's nothing telling me that I can use the data at all. They've got download links, but there's no instructions at all as to what they're expecting you to use it for. So, you know, the default policy is if you don't know, if you're not given an explicit license, you simply can't use it at all. And it's a shame because you've got a lovely data set there.
Yeah.
yeah, you know, most of us would agree that open is good equals goodness. I do worry
Yes.
at the moment because we are in a situation where there's a lot of politics around everybody from fossil fuel providers to boiler manufacturers to you name it, where basically if bad actors have good data, they may try to twist it in a direction we wouldn't want to see happening.
I don't think you can play that game. I think you have to do the right thing yourself. And if people do bad things with it, you get them for the bad behavior, not the good data. I just don't think you can hide data to try and make the bad guys suffer. I just don't think it works. Anyway, yeah, that's a philosophical.
I was just thinking about which, you know, whether you want to go all the way open so everybody can have everything, or whether you put some criteria on who can have stuff at this stage. And I'm not talking about what may happen in 2 years' time when this heat pump versus boiler argument is kind of more or less done, you know, and everybody knows that the heat pumps work. But at the moment, there are a lot of people, including journalists and God knows who wouldn't agree with that.
Hello and welcome to Fiona's little one.
Oh. Oh yes, hello.
Yeah, well, I mean, it is a nightmare.
Oh.
Oh, my
Okay,
goodness.
Oh, no.
Starting them young on heat pumps.
Yeah. It looks quite startled now.
Yes.
Okay, so anyone? We're a little bit over time, but I think it's been an amazing discussion. Anyone with any other questions for the great assembled knowledge that we got in this group before we close up?
Did you Fiona want to say anything about the research work that you were doing on
Me? Sorry, who are asking? Oh yes. So I was sort of interested from a perspective of someone who works for a low carbon energy consultancy, doing lots of projects for government and business and other quarters. One particular segment that I don't work on myself, but colleagues work on, is for network operators. So the distribution network operators who are, of course, will have to plan for what are the loads going to be for heat pumps in future. And this whole what are the loads for heat pumps is one of these sort of political footballs that gets you know, tossed back and forth of, you know, it's going to be, you know, it's going to be this much, it's going to be that much, it's going to cost whatever. And having a data set of very high you know, of high COP heat pumps that also are operated nice and smoothly and really showing what is possible, that seemed like a real asset to sort of that discussion, which feeds into I don't know, feeds into all these other sort of net zero heating discussions. But that was one sort of particular advantage or particular benefit that I thought of when we were sort of having these early conversations with Trystan and everyone else.
And also timing. You've not only got load, but you've also got timing, which the DNOs would love from a diversity point of view in terms of load and stuff.
Yeah, exactly. So I think there's potential for quite a bit of interest
from all sorts of different, different corners of people who are trying to do analysis on this of time series information, as well as from the COPs and SCOPs and how does the heat pump work? Understanding, things like the manufacturer data and are they performing, but also the larger network impacts.
Mhm.
Yeah, really good points.
Yeah, how much flexibility is possible and all of that.
Yeah.
Oh yeah,
yeah.
that's another one.
I mean,
Another whole
there's
can of worms there.
Well, that's a can of very nice worms, though. I mean, you've got really fine-grained data, and you've got, I mean, you'd like to have 3 million rows in that thing, not 30, but 30 is a really good start with good geographical spread.
Okay.